And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be using this older Raspberry Pi Model B to make a pattern generator for our vintage TV sets. Now this video, it's the second go I've had at making it. On account of a slight error, deleted all the original footage. The original idea was to use Python. I bought some books so I could learn something, and and use that to develop a switchable test pattern generator with, a few test cards on it. That didn't quite go to plan, but it did take me down an interesting avenue of reverse engineering. Let's get into it. Here's our setup. We have our Raspberry Pi. We have a push button connected between pins 6 and 12. There's our push button. That's going to be our safe shutdown button. I have composite video coming out of the yellow socket there. That's feeding the workshop monitor and the frame grabber, so you can sort of see what the output's like. USB power is being monitored here just because I'm interested in how much current it draws. I've got a keyboard here on plugged in there. So here's the SD card. This contains the image that I've just written, that I've downloaded from the MediaFire file hosting thing where I've placed it. So let's plug in and boot our Pi. There we go. Okay, so this is exactly what you'll see for the first time. Okay, so we have booted, but it's sat there and you'll see how it's loading failed. Now, just come down out of there. Let's just clear the screen just so we can see what we've got. If we type ls for list, we've got 3 directories there: music, scripts, and test patterns. So if we just cd music, change directory, and list, you'll see there's nothing in there. Likewise, let me just go back up, cd test patterns list, there are none. Okay, the reason that's not included in the image is because of copyright. I'm just going to, in fact, I could push the push button because this is the bit I can do. We can, of course, shut down with a push button. That's exactly the same script I used in the hospital radio streaming device that I built a couple of years ago. Okay, right, that's shut down. Now, what we've got to do is copy some images onto those 2 directories. There are various ways to do this. We can use SCP if we've got a Linux system, network in, SCP into there, using the username Doz, and the password is DTW, all lowercase. Doz is Television Workshop, DTW. It is set to auto login. If you are connecting this to your network, I think you ought to change the password because it's bound to be a security risk. There's no real reason to have it connected to a network, of course. You could just insert a USB stick and copy your images and music file from there. Now, here's one where I've done just that. So let's boot this version up. I think this boots faster because it's a slightly better memory card. Yeah. Okay, we're off. Now this video does look awfully flickery on here because it's interlaced, so this is proper PAL. It doesn't show up so much on the screen grab, I notice, but the actual images look fine. So in moments few we should boot. And there you have it, test card F. Now, my original thought was to use Python to query the GPIOs and have sort of like a rotary selector switch on the front for selecting between test patterns. I can't make that work, and I'll just quit out of here by pressing escape. You can also press Control C, because in Python I'm using a package called FBI. No, not the American lot. It's called Frame Buffer Imaging. So it allows us to display images on our console, which is exactly what we want. However, because FBI, once it's running, will not allow it to allow you to send commands from Python to move on to the next image. It will not even respond to the Control C or escape sent using SIGs in Python. So I'm not alone with this problem. There are many users that have had this particular issue. So yeah, not ideal. Anyway, if we just list again now, we CD music, list again, you can see we've got tcm.wav down the bottom there. So TCM is test card music.wav. Now, believe it or not, it's still playing in the background on this Pi. And I've done something reasonably clever here. So let me just get my audio jack. And if I go in this socket, we've got a tone. So that's coming out of the right-hand channel. And on the left-hand channel, I've got a little bit of test card music. I won't play that for very long because we'll probably get a copyright hit. So that is how the music works. So you need to copy a file called tcm.wav into the music directory on the card for it to work. Like I say, SCP if you've got a Unix system, or there is a Windows application that will allow you to SSH into the Pi. Right, let's come out of there and CD test patterns. Oops. Patterns. There we go. And if we list here, we've got some JPEGs, PNG there, a couple more JPEGs and PNGs. You can use almost any image format I found. BMPs even work, they're just a bit large, and of course we're compressed down to a PAL output. So there's no point in going mad. Right, let's have a look at the functionality of FBI. Okay, so we're back into our test card F there, and here's the reason I haven't included it in the image file. Copyright. Right, the key presses we need are J and K. So J advances through our test patterns. There's good old venerable test card C, look. There's a grayscale. There's some colour bars. There's a chunky crosshatch, a narrow one. The Native American Indian test pattern. Now this is looking odd on this screen. It's clearly not 1080 lines, but if that was being displayed on an analog CRT type widescreen TV set, that would look fine. So that's the reason I've included it, same as this one here. K goes backwards, J goes forwards, and it loops back round to the start. So that's great, but like I said, couldn't control it from GPIO. So I sort of went down a wormhole on the internet, and then I got to thinking, well, all I need to do is implement J and K. So that's what I did. Now, there are various Arduino projects that allow you to use the USB interface as an HID, a human interface device. Now that's a keyboard to you and me. But I got around to thinking slightly out of the box and thought, well, all I need to do is find an old keyboard, USB, but, you know, something a bit e-waste. This one isn't e-waste, so we're not going to be using that. But yeah, let me show you what I come up with. So like many, you know, roads and streets in towns, cities and villages all over the country, during lockdown, we started up a WhatsApp group. So I put out a plea on the WhatsApp group and said, has anybody got a keyboard, a USB keyboard that they don't want? And a lovely lady said, yes, of course. I've got one I'm about to throw away. Anyway, this is it, or I should say this was it. You will notice there's no USB lead. And this comes back to my comment at the start of the video where I lost the footage. So I'm going to take you through sort of what I did. So first off, there were a number of screws in the back. You can take those as read that they've gone. Then this thing sort of pops apart. I'm not really interested in being careful with it because this part of the keyboard is in fact scrap. So pop it apart. And you can see there's the keycaps. So that's redundant. And here is what we're left with. These are each individual keys. Now, by sort of lifting it up and down, I'd worked out that that's J and that's K. So what you need to do is discard the rubber part. And then we ended up with this thing that looks like a train track. Let me just switch to a graphic here and sort of explain how a keyboard's wired. Right, so here we've got a fictitious keyboard matrix. These are the switches for each individual one. I've got QWERTY U, obviously there's IOP and escape and those odd characters and the numbers above. But this is purely fictitious. And here we've got our J and our K. So when this switch is pushed, J connects X7 to Y2 and K connects X8 to Y2. This gives a coordinate for each of the keys. Q here connects X1 to Y1, W, X2 to Y1. Now, this might not be how our keyboard is wired. These X's and Y's are going to be largely erroneous. So let's go back to our keyboard and have a look, see how I reverse engineered it. Back in front of our keyboard, we have got two layers of conductive material, and these form our X and our Y. And let's just get rid of that. Thank you. This is when the black background of the bench actually comes in handy. So as you can see, that connected to a printed circuit board, and that's the bit I removed because here it is, and it's sat like that with the these two connectors resting on top here. And as you can see, we've got 3 wires connecting 2 push buttons, and that's because, purely coincidental in that diagram I did, the X coordinate here is the same for J and K. As you can see, I've marked out J and K on there, traced it through, it goes all the way around here and ends up on that pin there. Likewise, on the other side of the matrix, you can actually pin these out with a meter. J and K were here. Now, this matrix looks awfully complicated, so the trick was literally to buzz this out with a meter, just to make sure I had the right connections. Now, I've written on here 6 in was J, so I think it's 6 in on this one. 1, 2, 3, 4, 5, 6. as you can see, and 5 is K. So that gives us our X and Y coordinates. And of course, these are, you know, when these 2 bits of film pushed together, that's all it does. It just completes the circuit. So having worked out where our J and K were, it was very, very simple just to make that board up. Very, very simple to make our board up and just clean these contacts up. They had like a black, you can see that, they've got like a black conductive paint or print on there just to make sure the keyboard matrix makes good contact. But I cleaned that up with the old magic fiberglass pencil and managed to solder straight onto those positions. So that has given us a J and K push button. So yeah, just the job. And sure enough, if I connect this massively too long lead into our subject, our Raspberry Pi, that is the right card, and we apply a little power and we wait a second for it to boot up. Right, it's booted. So now you can see if we push that, that's our back button, and yellow is forward. It works perfectly. I'm rather pleased. So there's basically our system, but I'm not quite done yet. Now, obviously, most of the TV sets, the analog ones, we've got a mono output, hence this switchable 1 kilohertz and a bit of music. But actually, most of my television sets haven't got a composite video input. So that's not so much use to it. What we need to do is fit an RF modulator. So I've been on eBay. And we've got this Sony PlayStation. I don't know which variant of PlayStation that is, but it's an RFU adapter. These are great. I've used these before. Obviously, that's the connector that goes to the PlayStation. We can lose that. And then our RF out comes on this sort of switching unit, I suppose, or mixer unit there. We can largely do away with most of that as well, I would think. Or maybe we can fit that inside the box and not give us too much charge. But we can cut this off, supply it with power, supply it with composite video, and yeah, make ourselves a neat little unit. So the next job on the list is to make it into an enclosure. So here's one of these clamshell style enclosures. I'm not sure, it comes from Norman Harding. If you watched my video on the antenna, you'll remember that I visited there and I actually came away with a load of these. He's available as Seymour items on eBay. So maybe he's got some of these left if you want to purchase them. But the beauty is, of course, the front panel just sort of slots in like that. So I've been on Tinkercad and 3D printed a new front panel. So yeah, let's start getting this assembled. I have sort of started to mount things up a bit. I've got my Raspberry Pi mounted in my box there, 2M3 on a little standoff, just super glued to the case. It's working nicely. I've dremelled myself a slot in the side of the case that'll take the memory card. So, you know, just in case we ever need to update or whatever, we can do that. Button's still on there. I found a 3.5mm jack conveniently on a bit of lead, and a Gash phono socket for the composite video. So I think the next thing, oh yeah, also there's my 3D printed front panel. Not the tidiest thing in the world, but looks all right from a distance. So that'll do. Next thing to tackle is the RFU adapter. So we've got RF out coming out of here. So I'm thinking we may just put a Belling-Lee or maybe an F-type socket on the front panel there and go with that. Or, yeah, I quite like the idea of an F, but getting the video and power in it, we to work out what this lot is. So yeah, I think the idea here is we cut this off and have a little look and see what's going on in there. Or I could just disassemble the case. I wonder if it's possible to do that. Yeah. What I need is the vise. See if it'll pop open. So, one moment while I fetch that. There. I suspect it's a metal shielded container in here. So, I don't know but it's Sony. It should be half about. So, yeah. The output is, of course, fixed, certainly with this model, for UHF channel 36. But being as there's nothing going to be else connected to it, that should work well enough. Also, it's switchable between ING sound standards. I suspect in America that will be, I don't know, 1 or 2 of your VHF channels. They normally are, aren't they? But not here in the UK, certainly, or Europe as it would be. So let's just squeeze that up and see if it yields. Don't think it's keen, is it? It's got a bit of a screwdriver in there as well. Yeah. Oh, there we go. Yeah, as I suspected, look. We've got a little metal can in there, which will be much easier to deal with than our big thing with a strain relief on it. Okay, put the vise back out of the way. Yeah, so, right. Now we're going to work out which is power and which is ground. Clearly the shielding is going to be ground. And I just want to mark up that switch, just so we get it around the right way. That is I, and this is G. I, G. Okay. Right, so I seem to remember this being wired oddly last time I went to use one. And 5 volts wasn't. So let's just peel back here and see what we've got. So the shield is quite clearly black. Let's just confirm that. So bring in the meter. Beep range. So case to that one should be ground. It is. Now, if we measure the resistance here, this probe's got bent, isn't it? Let's go into resistance. So across the video, we'd expect to find 75 ohms. I'd expect it to be yellow, but that's 12k. What's white? So white is 77 ohms. That's going to be my video, isn't it? Yellow is 12k. Red is open circuit. So I'm wondering if red is our 5 volt supply. So let's generate 5 volts. I'm going to cut all these wires off. Red is possibly our 5 volts then. So I'm going to limit a current supply into that. I'm going to pop the workshop TV set on, tune it to channel 36 and see if we get a carrier. I need my strippers. Right, so I've got the red exposed. The TV, of course, might not lock on if we've got no video present, but we'll have a look. Blast, wrong kind of lead. I'll just pop it straight into the back of the monitor. Take this elastic band off. Input, SCART, PC. Oh, missed it. Snow good, brilliant. Okay, so there, if you can see, is the output to the monitor. Now I think that's 5 volts then. So let's get some crocodile clips. Nope, not crocodile clips. Yay. So that's ground. We think the audio's yellow and we think video's white. So let's pop that on there and just turn the current up a little bit. Interesting. It's drawing absolutely nothing. And we've got 5 volts there. So that may not be our video. That may be audio then. So let's try the white lead. Right. That is now consuming current. Let's just gently ebb that up a little bit. It's consuming a fair amount of current. Tell you what, white was video, wasn't it? That was our 77 ohm resistor. So thankfully we haven't put any power into it yet. It's always prudent, isn't it? It's yellow. Is yellow going to be our power? Interesting. I've just got a twinge of something on the screen there. I don't know if you saw that as I made the connection. Oh. Right, we do have a twinge of something. So let's just go into setup. Manual tuning. Yes. I'm on channel 31, so I want to be upwards from there, don't I? 33, 34, 35. Yes, look at that. So, come back. That'll do. Channel 36, and you can see that's black. So we come out of there, off, on. So yellow is our 5 volts. Red is probably audio, actually. White's our video. I'm fairly sure that's where we're going. Okay. So we need to extend these leads and derive a 5 volt supply, probably from the Pi. Be the most sensible thing, wouldn't it? So let us get back to mounting this in the box. I've got bits sort of lashed up here now. We've got the Pi connected to the modulator, I think the right way around. Modulator set to I, got a bit of sound going in there. 5 volts is coming from the external supply. Let's switch on and see what we get. Oh, we have video. Picking up a lot of interference on the sound. We may be able to do something with that anyway. But what you're seeing now on the monitor is actually RF. There's nothing connected to the composite video. It is purely that RF signal. So if I just go around the menu, there you go, AV1, SCART, PC, and back to TV. And of course, I've lost the tuning because I never stored it. Setup, go. Manual tuning, go. 32, 33, 34, 35, 36. Ah, well, back. Ah, good. And we've got a tone. Tone seems to be very low and very noisy. Yeah, it's all sort of going on there. But there you go. We have it running and producing a picture on RF. You'll notice it's nowhere near as sharp as it was on video, but that's okay. That's what we expect. So all in all, I'm quite pleased with that. Right, I've just got to put the rest of it together, mount the front panel up, tidy up our wiring, so we can sort that sound out. That's making awful noise, but we've got an awful long length of lead here. Oh, there we go. Much improved. In fact, too loud. Good. Let's hit the shutdown button. And there it goes. So that's sort of initial tests complete. Brilliant. Moving on. Right, I wasn't very happy with my first 3D printed front panel. So I've 3D printed another one, just a simple black shape with the relevant holes in it. I've used the nasty sharp Chinese torch tool there just to ream the hole sizes out so all the switches and LEDs and things fit in there. And I know what you're saying. What are you going to do for the front? Well, we've been on Inkscape and I've designed myself a front panel. Just switch that on. That's sort of going to line up like that. I've just printed it out and laminated it onto it, make it a bit shiny and pretty. And yeah, we can line that on that, bond that to there. And yeah, it should look very good. So to get the alignment right, I'm just going to get a bit of this heavy duty sticky tape. Just want a bit. Don't ever try and do this with your teeth, it doesn't work. It's very, very strong stuff, this is. Right, it's got a bit of that. I'm just going to stick that on the end there. And then I'm going to get the alignment somewhere near. Thankfully, it actually printed at the top of the page. It's funny, on the laser printer, it printed in, I was doing sort of drafts for it, it printed portrait, and this time it's done it, sorry, landscape, and this time it's done it portrait on the colour printer, but hey. Let's just turn the brightness, oh, brightness was turned up on there. Right, so we just got that in position. Just stick it down on the end there. Just going to pop the LED board out the way temporarily. Bring in some adhesive. This is Yoo-Hoo. You can use other stuff, I'm sure. I'm just going to fold that back and spread a layer of glue right into the edges. Right, that's enough spread on there. And I shall use my inbuilt glue spreading tool. Make sure that gets right into the edges. Excellent. Yeah. Wipe the excess glue off your inbuilt spreading thingies and yeah, fold that back over. We'll just pick it up, pop it back on the LED board quickly. Just check the alignment. Looking good. Give that a good firm rub down. wipe the glue off that in a minute. There. Now I'm just going to leave that for about an hour to dry. Right.
1 hour later. What follows is a brief construction montage.
Snug as a bug in a rug. Right, so got a little bit of wiring to do. Let's crack on with that, and I'll see you back when I'm finished. Right, some time later. There it is, it's complete. Front panel's all up together, I'm pleased with that. Wiring's all done. What remains to do is to put the lid on and power it up. So be a bit careful with some of the wiring there. Try not to get the front panel caught under this edge. It's looking quite reasonable. That's quite a smart looking instrument. Right, let's get a couple of screws in it. I've caught a bit of wiring on that side actually. I sort of feel something. No, we appear to be alright. It's probably the front panel's just a shade oversized maybe. What a thing. So let's switch it on. Oh, I opted for USB power, by the way, because I've always got USB in the workshop. Let's spin you around so you can see what's going on the monitor. It does take a... Oh, that's it. It does take a minute or two to boot. Oh, come on. So there we have it. I'm just going to switch the music off again before we get done. There's a tone. Go forward in our pictures. And back. As before. Again, when I ship the image, there'll be some copyright-free pictures. I've actually made an instruction screen to show you how to get your own pictures on there and your own music, because, like I said, this will undoubtedly infringe somebody's copyright. So there we go. That's it, complete. The Raspberry Pi PatGen. If you make one, let me know. Full instructions will be on the website. So that's andydoz.blogspot.com. Go and have a look at the full instructions on there, and let me know how you get on. I reckon that's a really useful addition to our workshop. Nothing more to say really, other than thanks for watching. Stay tuned very soon here on Doz's Television Workshop for some more audio or television shenanigans. I don't know what's coming up next, to be honest. But yeah, that's it for now. Like, subscribe, dislike, whatever you want to do. And I'll see you really soon here on Doz's Television Workshop. Bye. some time later. Let's just do that again, shall we? Hello, and welcome back to Where the Hell's the Raspberry Pi? Let's do that again. Hello! Hello, and welcome back to Doz's Television Workshop. This video has been a nightmare to make because I'm now farting and it's really bad. Start again. And welcome back to Doz's Television Workshop, where today we're going to be using this ancient Raspberry Pi. It's not ancient, is it really? Initially, I made this video and let's start again. Model B. Let's do that again. We'll get there in a minute. We will. Nicely, and yeah. Initially, I went. My goodness. And see how we get on. Don't know whether that works or not. Just take the cards out, take the footage off, put the blank. Jesus Christ. Pi. This is an old. This Television Workshop. Let's put the other glasses on. I can't even see where I'm going, man. What do I look like on camera? How's the hair? The hair's terrible. That's it.